Hi everyone, so first of all thanks for having me along today. I'm based at UWA in the School of Agriculture and Environment and also in the Centre for Water and Spatial Sciences. So my background is in remote sensing, geospatial software development and machine learning, and so that's kind of the perspective that I come from when thinking about mapping urban landscapes and trying to detect change in urban environments. I want to spend a few minutes today just introducing a new project that we've got starting at UWA that's actually being led by Brian, who's sitting over there. And it's a collaboration between UWA and RMIT, and with a lot of support from Nearmap in terms of access to their AI-derived geospatial data. The project's funded by the Australian Research Council, and the overall goal of the project is in Perth, Sydney, Melbourne, Adelaide, and Brisbane to detect all the cases where there's been residential change, and then to identify what the warming and heat impacts of those cases of residential change has been over the past 10 to 15 years. And the project's sort of centered around three core objectives. The first objective is to take all the residential parcels in those 5 cities, and then for multiple time points to go into a lot of detail and map out what's actually going on in each parcel and to identify the type of residential use in that parcel. And then doing that for multiple time points, we can identify where there have been cases of residential change. The second objective is to take all these cases of residential change we've identified in Objective 1 and then link them with temperature data sets and sort of causally identify how different types of residential change have altered the temperature exposure in residential neighbourhoods. And then the third objective, which is actually unhelpfully labelled Objective 4 here, is a policy analysis that's being undertaken by RMIT. And that's looking for overlaps between existing regulatory and planning controls and the cases of residential change where we see the most adverse heat impacts. It's sort of, I guess, trying to understand how fit for purpose existing sort of regulatory environments and policy is for the way that our environments have been changing and thinking about sort of as climates get warmer and the heat exposure of residents. So we started work on this project really in February, and so we're making good progress towards Objective 1, so mapping residential landscapes. And so I'm going to spend the next couple of minutes just talking about some of our initial results. This is a visualization of the kind of data that we're primarily working with. Some of you might recognize it as part of White Gum Valley and Fremantle. I think that's the sort of edge of Boombara Park up there in the golf course. This is data that's provided by Nearmap, and it's their AI product. And the way this data is generated is Nearmap fly aerial surveys over Australian urban areas at a pretty frequent cadence. And these aerial surveys generate RGB imagery. And this RGB imagery is passed through their AI system. And this AI system works by looking at each 7 by 7 centimeter pixel footprint and then assigning that pixel a probability that it belongs to one of about 70 different surface cover classes. And so we're working with a subset of these surface cover classes that you can see here. So things like the different types of vegetation mixes that go on in a parcel, the different types of impervious cover, so where there's asphalt, where there's concrete slabs, where you've got other hard surfaces, the building footprints and the 3D attributes of buildings, and a few other useful classes as well, so the areas where you've got soft pervious cover. So there are a couple of attributes of this data set that are really valuable. One is it's just incredibly fine spatial resolution, means that we can zoom in on an individual parcel and map out what's going on there in a lot of detail. The second is that it's all generated using one model. So this means that we can use it for doing cross-city and cross-time comparisons and minimize the amount of bias that might come into those change detection analyses through using different data sets or different methods. So if we take that data but then scale it up to the city level for a couple of different time points, we can produce these kind of change maps that you can see here. So here I've just pulled out a couple of different surface cover classes, so asphalt, lawns, swimming pools, and soft and pervious surfaces, and summarised their cover up to the mesh block level for 2010 and 2023. And then sort of the third map in each panel is showing the percentage change in that cover class between 2010 and 2023. So the blue shades are where you've seen a mesh block that's had an increase in that type of cover, and the red shades are where you've seen a decrease in that type of cover. And so, yeah, you can see some really interesting patterns in how the surface cover of Perth's urban sort of landscape is changing over time. So we've kind of got down our workflow for mapping out surface cover at scale, and we're now sort of focusing on developing metrics that allow us to characterize the arrangement of urban elements inside each parcel, and also to begin thinking about how we can map out the type of residential use that's occurring in each parcel as well. And so this is a schematic of the method that I'm sort of putting together at the moment, working a lot with Warren, who's at the back with the camera. But what we're doing here is we're taking the NearMap AI data and we're putting it through a GIS system that we've built that spits out a suite of different surface cover and built 4 metrics, the kind of things you can see in the top table on the right, that are descriptive of what's going on in that residential parcel. We're then taking an image of the parcel and we're combining it with those GIS-based metrics and passing that into an AI classifier that we're training at the moment. And that AI classifier assigns a probability score to that parcel that it belongs to one or more different types of residential use on that parcel. So the types of residential use that we're considering are largely drawn from the CRC for water-sensitive cities infill typology, but it includes things like a single detached house, multiple units on a lot, terraces, townhouses, apartments, and then other types of uses of parcels as well, and kind of an indication of what that might look like there. So then for each parcel, we have a vector basically of GIS metrics that are descriptive of what's going on inside that parcel, and then another vector of probability scores that tell us how likely that parcel is to be of this type of residential use. And we combine both of those vectors of numbers together, and that becomes our sort of single database entry for what's going on in that parcel at that point in time. So the final thing that we're trying to do in that first objective is to map change. And the challenge that we've got is for each parcel, we have many, many different variables that describe different attributes of that parcel. So how can we consider all of these different variables? Some of them have different units, some of them are more qualitative, some of them are much more quantitative, but combine them all together from multiple time points and come out with one number that's an indication of the magnitude of change that's going on in that parcel. And so again, I've done this here at the mesh block level just so the patterns pop out at the city scale. But we're using some statistical techniques that are based upon information theory, and they allow us to bring in many different variables, consider how they're changing over time, and then we get a single number out the end that is indicative of how much change has gone on inside that parcel. And this gives us a heat map like you can see here, where this map here is considering all these different variables and a few more that I've got on the left, and it gives us one number out on a scale where 1 is the most change, like the parcel is completely different in terms of the surface cover that's there, and 0 is there's absolutely no change. And so you can see areas in yellow where there's a lot more change occurring. So that's pretty much where we're up to at the moment. Hopefully in the next sort of year or two, we'll be able to report back some interesting findings where we've built these kind of city scale maps of residential use, again using a single model so we can do cross time and cross city comparisons, and also begin to link these maps with temperature layers and begin to pinpoint exactly how different types of residential developments across the 5 cities have caused different types of warming outcomes to occur. So I think that's pretty much it. But yeah, very happy to take any questions.